Welcome back to the Deep Dive. Today, we're going deep into Hadoop, but with a twist. We're tailoring it specifically for you folks, who are already comfortable in the world of relational databases.
Yeah, that's right. Think of it as like bridging the gap, right? Between what you know and this whole world of big data, those massive data sets that traditional systems just weren't really built to handle.
Okay, so let's unpack this. We've got all our sources here, all about the core components of what makes up the Hadoop ecosystem: HDFS, MapReduce, Hive, Pig, and Sqoop. That's a lot, but we're going to focus on how they work together, and more importantly, I think, how they compare to what you're already used to.
And why you should even care, right? It's one thing to just learn the parts, but the real value is understanding how Hadoop solves the problems that might be starting to cause you headaches in the relational world.
Exactly. So let's start by painting a picture, right? You know how traditional BI relies on this neatly structured data, often stored in a single relational database? What happens when that data just explodes in volume, starts coming in so fast, and it's not so neat anymore?
Yeah, you hit the limits of what those systems were even designed for, right? Think about the sheer scale. We're talking 90% of the world's data being created in just the last 2 years. Like, that kind of volume and velocity just overwhelms traditional approaches.
What, 90% in just 2 years? That's wild. No wonder we need a different approach.
Yeah.
So Hadoop ditches this whole idea of keeping everything in one place, right? It goes and distributes that data across a whole cluster of servers. How does that even work?
That's where this thing called the Hadoop Distributed File System comes in, or HDFS for short. Imagine you have this, massive file, way too big for any single machine. Now picture, splitting that file up into chunks and putting those chunks on, different servers, different shelves, right?
Yeah.
That's essentially what HDFS does. It's, but obviously with a lot more smarts built in.
Okay, so instead of one giant database, we're talking about a whole network of machines, each holding a piece of the puzzle.
Yeah.
Makes sense for storage, but how do you actually do anything with the data? Do I have to log into each server separately to, run queries?
Not at all. That's where the magic of MapReduce really comes in. So think of it this way. You've got this huge task, right? Like analyzing website logs to figure out user behavior patterns. Instead of doing it all on one machine, you split the task into smaller, independent chunks. Each server in the cluster takes a chunk, processes it, and then sends its results back to be combined, right? So that's MapReduce, in a nutshell, parallel processing at scale.
Ah, so it's like dividing and conquering the data.
Yeah.
Sounds efficient, but wouldn't managing all those servers and writing custom code for each step be a total nightmare?
Yeah, and that's where Hive comes to the rescue. Remember SQL? The language you use to query relational databases. Well, Hive gives you a very similar interface to interact with data that's stored in HDFS. So if you're comfy with SQL, you can actually leverage those skills to analyze data in Hadoop. You don't have to learn a whole new programming paradigm.
Okay, so Hive is like a translator, letting me speak SQL to Hadoop. That's a relief. But what about those times when SQL isn't enough? When you need to do something more complex, more that unstructured?
For those situations, you've got Pig. It's a scripting language, specifically designed for data manipulation within Hadoop. It's more flexible than Hive. It lets you express complex data transformations and workflows that would be really difficult or even impossible to do with plain SQL.
So if Hive is SQL for big data, Pig is like the power tool for those really tricky, data wrangling tasks. But what about all the data I already have in my existing relational databases? Do I have to abandon all of that to even use Hadoop?
Not necessarily. That's where Sqoop comes in. It acts as a bridge, right, between your relational databases and this HDFS. You can use Sqoop to import data from your existing systems into Hadoop for analysis, or even, export data from Hadoop back into a relational database if needed.
So Sqoop is like the data ambassador, ensuring smooth communication between these two worlds. It's starting to feel like Hadoop has a tool for just about every scenario.
That's definitely one of its strengths, It's a comprehensive ecosystem. It was designed to handle the entire life cycle of big data, from storage and processing to analysis and even integration with your existing systems.
It's impressive. But you mentioned earlier that Hadoop really shines when it comes to batch processing. Can you elaborate on what that means and why it's such a big deal?
Absolutely. Batch processing is all about handling large volumes of data in a non-interactive way. So think about tasks like generating reports, analyzing historical trends, or even training machine learning models. These are jobs that they don't need to be done in real time, right? They can be executed kind of in the background.
So it's like setting a big pot of data to simmer on the stove. You don't need to constantly stir it. You just let it cook until it's ready.
Exactly. And because Hadoop can distribute these batch jobs across its cluster of servers, it can churn through massive amounts of data way more efficiently than a traditional single server setup. It's like having a team of chefs working in parallel instead of just one.
Okay, that makes sense. So Hadoop is great for batch processing because it can just divide and conquer those large jobs. But how does it actually achieve that efficiency? Like what's happening under the hood?
Well, remember those MapReduce tasks we talked about earlier? Those are the key. Each server in the cluster can actually execute multiple MapReduce tasks at the same time, concurrently. And because the data is already distributed, across the HDFS, there's no need to move these large files around. This parallel processing, combined with data locality, is what gives Hadoop its batch processing muscle.
It's like having a factory with specialized workers, each one focusing on a specific part of the production process. No bottlenecks, just smooth, efficient execution.
That's a great analogy. And it's this efficiency that's made Hadoop so popular for tasks like data warehousing, log analysis, and even scientific research.
So this is really starting to come together, right? We've got data distributed across a cluster of servers, processed in parallel using MapReduce, and then accessible through familiar tools like Hive and Pig. But I'm curious, how does all of this actually impact, me, the person who's used to the world of relational databases? What are the real-world implications of using Hadoop?
That's a great question, and it's one we'll dive into deeper in the next part of our deep dive. We'll explore how Hadoop can help you overcome those limitations you might be facing with relational databases, and we'll look at specific use cases where Hadoop truly shines.
All right, so we've kind of laid the groundwork here. Hadoop's all about distributing data, processing it in parallel, and providing the tools to make that whole process manageable. But I'm eager to hear more about those real-world implications you mentioned. How does Hadoop actually change the game for someone coming from a relational database background?
Well, one of the biggest shifts, I think, is the sheer scalability. Hadoop lets you work with data sets that would be honestly just impossible to handle in a traditional relational database. Imagine you're an e-commerce company, right? You've got years of customer purchase history, website, clickstream data, all those social media interactions. Trying to analyze all of that in a single relational database, it would probably just bring your system to its knees.
Yeah, I can definitely see how that would quickly become a bottleneck. So Hadoop lets you break free from those limitations and analyze data at a scale that was previously unthinkable.
Exactly. It opens up a whole new world of possibilities. For example, you could use Hadoop to identify hidden patterns in, customer behavior, personalized recommendations, optimize pricing strategies, or even try to predict future demand. These are insights that were just completely out of reach before.
It's like going from a magnifying glass to a high-powered telescope,
Yeah.
Suddenly you can see so much more detail, so much more depth.
That's a great way to put it. Another key advantage is fault tolerance. In a traditional relational database, if your server goes down, you're in big trouble. But with Hadoop, the data is replicated across multiple servers. So if one server fails, the system can, keep running. You don't lose any data.
That's a huge relief, especially when you're dealing with mission-critical data. Loss of data could be, catastrophic. So Hadoop provides that level of resilience that's just hard to achieve with a single point of failure.
Absolutely. And then there's the cost factor. Hadoop is designed to run on commodity hardware, right? Which means you don't need to invest in these expensive specialized servers. This makes it a much more cost-effective solution for handling these, large data sets, especially compared to trying to scale up a traditional relational database.
Yeah, that's a really important point, especially for organizations that might be hesitant to jump into big data because of the perceived cost.
Yeah.
So Hadoop kind of democratizes access to big data analysis by making it, more affordable.
Exactly. It levels the playing field, allows even smaller organizations to kind of leverage the power of big data. But it's not just about cost, right? Hadoop also offers a lot of flexibility in terms of data types. Relational databases, they're great for structured data, but they really struggle with unstructured data like text documents, images, videos. Hadoop, on the other hand, can handle all sorts of data, structured or unstructured.
That's a game changer. It means you can analyze data from a variety of sources without having to force it into a rigid schema.
Exactly. You can combine data from, social media feeds, sensor logs, customer reviews, even satellite imagery, right? To gain a much richer understanding of whatever it is you're trying to analyze.
So Hadoop breaks down those data silos, allows you to see the bigger picture. That's incredibly powerful. But with all this talk about, distributed systems and parallel processing, I can't help but wonder about security. With data spread across so many servers, isn't it inherently more vulnerable?
That's a valid concern. And security is definitely a top priority in any Hadoop environment. Fortunately, Hadoop has evolved significantly in this area with robust mechanisms for authentication, authorization, and data encryption.
So it's not just about making data accessible, it's about making sure it's accessible only to the right people.
Exactly. Hadoop uses tools like Kerberos, which is this network authentication protocol. It ensures that only authorized users can actually access the cluster. Think of it as a strict bouncer at the door of your data center, checking everyone's credentials.
I like that analogy.
Yeah.
So Kerberos is the first line of defense. But what about controlling what users can actually do once they're inside the cluster?
That's where authorization comes in. Hadoop lets you define really granular access controls, specifying which users or groups have permission to read, write, or even modify specific data sets. You can even control access at the file level, ensuring that truly sensitive information is protected.
It sounds like Hadoop provides a layered approach to security, from controlling access to the cluster itself to restricting actions within the cluster. That's reassuring, especially when dealing with sensitive data.
Absolutely. And then data encryption adds another layer of protection, right? Scrambling the data so that even if it's intercepted, it's unreadable without the decryption key. Think of it as putting your data in a safe that only authorized users have the combination to.
So these security measures are essential, especially with growing concerns about data privacy and regulations like GDPR. So Hadoop not only enables powerful data analysis, but it also provides the tools to do it securely and responsibly.
Exactly. It's a comprehensive platform that addresses both the opportunities and the challenges of big data. But while security is crucial, there's another aspect that's often overlooked: monitoring.
Monitoring, what do you mean by that?
Well, when you have this, distributed system like Hadoop with data and processes spread across all these different servers, it's essential to have a way to track what's happening across the entire cluster. You need to know, if the servers are healthy, if jobs are running smoothly, and if there are any performance bottlenecks.
So it's like having a dashboard for your Hadoop ecosystem. Gives you visibility into the health and, the status of the entire system.
That's a great way to put it. Hadoop provides tools that allow you to monitor key metrics, things like CPU usage, memory consumption, network traffic, disk space. You can even set up alerts so you're immediately notified if anything goes wrong.
That sounds pretty crucial for ensuring the smooth operation of a Hadoop cluster. You don't want to be caught off guard by, a failing server or a performance bottleneck that's slowing down your analysis.
Exactly. Proactive monitoring allows you to identify and, address these issues before they become major problems. Ensures that your Hadoop cluster is running at, peak performance.
So this monitoring aspect, it adds another layer of, complexity to managing a Hadoop environment. But it sounds like it's a necessary complexity given the, distributed nature of the system. So Hadoop is powerful, it's scalable, it's secure, and now we see it's also monitorable.
Yes. And all of these features come together to make Hadoop a really compelling solution for organizations that are looking to, extract value from their big data.
It's been a fascinating journey so far, from understanding the core components to exploring these security and monitoring aspects.
Yeah.
But I'm curious, how do things like virtualization and cloud computing fit into the Hadoop world? They seem to be transforming the entire IT landscape. So I'm wondering how they're impacting Hadoop deployments.
That's a great question. And you're right, virtualization and cloud computing are having a really profound impact on how Hadoop is, being adopted and used.
So we've covered a ton of ground in this deep dive, from the nuts and bolts of how Hadoop actually works to the security and monitoring stuff, right? The things that keep it all running. But before we wrap up, I'm really curious about virtualization and cloud computing. How are they changing the Hadoop game?
It's a big shift, Back in the early days, setting up a Hadoop cluster meant you had to invest in all this physical hardware, configure servers, and basically manage this whole infrastructure yourself. It was complex and expensive, which meant that only these larger organizations, the ones with a ton of resources, could really use Hadoop.
Yeah, that makes sense. But virtualization and cloud computing seem to be breaking down those barriers. How so?
Well, virtualization lets you run Hadoop on on virtual machines instead of physical servers.
Right.
So this means you can spin up a Hadoop cluster on existing hardware or even on cloud infrastructure without having to physically manage a bunch of servers.
So it's like creating a virtual Hadoop environment,
Right.
which is way more flexible and scalable.
Exactly. You can easily adjust the size of your cluster, adding or removing virtual machines as you need. This makes it a lot easier to scale your Hadoop resources, up or down to match your workload.
That's a huge advantage, especially when you're dealing with like data volumes that fluctuate or processing needs that are unpredictable, right?
Yeah.
No need to over-provision hardware just in case. But how does cloud computing fit into all of this?
Cloud computing takes virtualization like a step further, right? By offering Hadoop as a service, so platforms like Amazon EMR or Microsoft HD Insight, they offer pre-configured Hadoop environments that you can just access on demand. You don't have to worry about setting up or managing any of the infrastructure. It's all handled for you.
So it's like having Hadoop on tap. You just turn it on, use it, and turn it off when you're done. That sounds super convenient.
It is. It really lowers the barrier to entry for organizations that, they want to play around with Hadoop or use it for like specific projects without having to commit to a full-blown on-premise setup.
This cloud-based approach seems like a total game changer.
Mm-hmm.
It makes Hadoop so much more accessible to a wider range of companies, right?
Right.
Regardless of their size or technical expertise.
Absolutely. And it also has implications for cost, right? With cloud-based Hadoop, you pay only for the resources you actually use. This can be a significant cost saving compared to, maintaining your own infrastructure, especially if your Hadoop usage is kind of sporadic or unpredictable.
It seems like virtualization and cloud computing are really like democratizing access to Hadoop, making it a viable option for organizations of all shapes and sizes.
Yeah, they really are. And this trend, I think, is only going to accelerate as cloud platforms continue to evolve and offer even more sophisticated Hadoop services.
It's a pretty exciting time to be involved in the world of big data, wouldn't you say? Hadoop has come a long way since its early days as a specialized technology for tech giants. Now, with virtualization and cloud computing, it's becoming a mainstream tool for data analysis and insights.
I couldn't agree more. And as Hadoop keeps maturing and evolving, we can expect even more, innovative applications and use cases to emerge.
So we've covered so much today, from those fundamental building blocks of Hadoop to the ways it's being, reshaped by virtualization and cloud computing. For those of you who are already comfortable with relational databases, I hope this deep dive has given you a really solid foundation for understanding, how Hadoop works, its strengths, and its potential.
And I would add that what's really fascinating is how Hadoop is not just about technology. It's about empowering you to ask and answer questions that were previously impossible. It's about unlocking new insights, making better decisions, and ultimately driving, innovation and progress.
That's a great way to put it. And we always like to leave our listeners with something to ponder. So as you continue your journey into the world of Hadoop, think about this. How can you use the power of this technology to transform the way you work with data? To break free from the limitations of, those traditional approaches and to unlock all these new possibilities for your organization?
It's a question worth exploring, and who knows what amazing discoveries lie ahead, right?
That's all for this episode of The Deep Dive. Thanks for joining us on this journey into the world of Hadoop. Until next time, keep diving deep.